Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over problem number 1 of the 2018 AP Calculus AB free response question, and it focuses on flow rate and tables. All right, let's take a look at question 1, part A. Now, in this question, we're being assessed on how to estimate the derivative using the average rate of change. Okay? All right, so question 1 reads, it says, grain is being added to a silo. At time t equals 0, the silo is empty. The rate at which grain is being added is modeled by the differentiable function g, where g of t is measured in cubic feet per minute for 0 less than or equal to t less than or equal to 8 minutes. Selected values of g of t are given in the table above. So we have the given table right here. Question A, 1A. Using the data in the table, approximate g prime of 3. Using correct units, interpret the meaning of g prime of 3 in the context of the problem. All right, to get started, let's go ahead and write down the formula that's going to guide our problem solving process. All right, so don't forget we have the collection of your must-know calculus formulas on our website at Mathgotserved.com, so do check it out. All right, so for a less than or equal to c less than or equal to b, basically if we have c in between a and b on the real number line, so let me just give you a visual of what we're talking about. So if it's given to you in a tabular format, what you're looking at is if you have an interval, and let's say you have c right there in the center, you have a table like this, and then you have your a value and your b value, and then you have some c in between a and b. Okay, so the assumption here is that you have a function that's continuous and differentiable. So the instantaneous rate of change of the function at x equals c, at that c in the interior, can be approximated using the average rate of change, all right, on the interval containing c. Another way to write this is that the derivative f prime at c is the same thing as the instantaneous rate of change at c, okay? And this derivative can be estimated using the average rate of change, f of b minus f of a divided by b minus a. This is like the conclusion of the mean value theorem, right? If you have a function that's continuous and differentiable on an interval a, b, then there's a c in that interval where the derivative at c is equal to the slope of the secant line through AB. Alrighty, so this is the formula that we're going to be using for this problem. Alright, so let's go ahead and get started. We want to start off by estimating what g prime of 3 is, and then g prime of 3, and then we are going to talk about what it means. So to estimate, we want to estimate g prime of 3. Now I just copied the table and compressed it and pasted it right here. Now with this table we can ascertain what A and B are. I didn't take the entire table, I just took a part of it. Now, why did I take this part of the table? Well, we're looking for the portion of the initial table, so it goes from 0 all the way to 8, that contains this value 3. Okay, so 3 is located where? That c value, which is 3, is located in between 1 and 5. So c is 3. Okay, so if c is, that's the interior point right there, then guess what? Our b is going to be 5 and our a is going to be 1. Okay, all right, so let's go ahead and write that down. So a is 1, b is 5, and c is that interior point, that point in between 1 and 5 that satisfies this conclusion. So c is equal to 3. All right, so whenever you're asked to estimate the derivative, you just look at a table and pick the interval that contains a number before and after the particular x value you find in the derivative at. Alrighty? Okay, so let's go ahead and apply this formula right here to this scenario that we are dealing with. So g prime of 3 is going to be, it's approximately, so let's use approximates here. So g prime of 3 is approximately g of b minus g of a, g of b minus g of a, which is g of 1, divided by b minus a, which is 5 minus 1. Okay, so I'm just applying this formula here, and let's work that out. So using the table, just substitute 20.5 minus 15.1 divided by 4. And then this is a calculator active part of the AP exam, so you can just use your calculator to compute what the value is. So if you do that with your calculator, you end up with 1.35. Okay? All right, but we were asked to specify the answer using correct unit. So what's the unit here? All right, so to figure out the unit, let's just use ARR. So we have amount, rate, and rate of rate. Okay, when you're going down our continuum here, what you're doing is you're differentiating with respect to time. So d dt. All right, so when you're differentiating with respect to time, what is happening to the unit? If you look at the operation here, you have a dt, a time value in the denominator. So what you're doing when you differentiate is that you're dividing by time every single time you differentiate, okay? So for the amount, could be cubic feet. We're told here that the rate g of t is cubic feet per minute. So g is right here. G is the rate, and it's cubic feet per minute. All right, so the unit of time here is cubic feet. So when you go, the unit of time, sorry, is minutes. So when you go from the amount to the rate, you divide by time, which is minute, okay? But here we are estimating g prime. So if g is right here, so this is g, the rate, and then this is basically the integral of g, then this is g prime. This is what we just found, all right? So if you differentiate a rate cubic feet per minute, guess what your unit is going to be? Your unit is going to be cubic feet per minute, or cubic feet per minute square. Okay, an analogy is, think about SIVA, for example, position, velocity, and acceleration, right? So velocity is meters per second. And what's the unit for acceleration? As meters per second square. Okay, so basically, remember that anytime you're differentiating a rate function, you're going to be dividing by time as long as you're differentiating with respect to time. All right, so the unit here is 1.35 cubic feet per minute square. That's the unit. Okay, so now that we have the answer, let's rewrite it again. So g prime of 3 is equal to 1.35 cubic feet per minute square. Okay, now what is the significance of this answer? We want to say what this answer means within the context of this problem. All right, so to do this, we're going to be using our super gun chart here, okay? All right, because the rate, the derivative is actually g, so let me show you exactly what's going on. So you have a function, the derivative, and f double prime, second derivative. So this g of t is a rate, okay, cubic feet per minute. So g is going to be right here, okay? And then this would be the integral of g, and then this would be g prime. Alrighty? Okay, so let's complete our fun charts. Actually, our super gun chart here. So here is concave up, down, increasing, decreasing, positive, negative, and then increasing, decreasing, positive, negative. All right. So in this particular problem, we found out that G prime was positive, okay? So G prime, the derivative of this rate was positive. So what does that tell us about G? If G prime is positive, that tells us that G, the rate, is doing what? The rate is increasing, okay? And at what rate is it increasing at? It's increasing at 1.35 cubic feet per minute square. Alrighty, so let's go ahead and write that down real quick. So let's start by saying G prime of t is positive because we have 1.35. And then if G prime of t is positive, what does that mean? It tells us that the antiderivative G is increasing. Okay. All right, so let's go ahead and write down what this means. I just replaced the t with a 3. All right, so the meaning of this is as follows. The meaning of our answer is that at time t equals 3, G of t, the rate at which grain is being added to the silo. So G of t, the rate at which grain is being added to the silo is doing what? G of t, the rate at which grain is being added to the silo, is doing what? It's increasing. All right. All right, so increasing is the rate of change of the rate of change, which is the second derivative. It's increasing at what rate? It's increasing at 1.35 cubic feet per minute square. Okay, let me correct my unit here. So not meters square, it's per minute square. So that's basically what the answer to question number 1A means. All right, let's take a look at question 1B. On question 1B, we're being assessed on how to use the right Riemann sum to estimate the value of an integral. Okay, so the question reads, write an integral expression that represents the total amount of grain added to the silo from time t equals 0 to time t equals 8. Use a right Riemann sum with 4 subintervals indicated by the table to approximate the integral. All right, so let's go ahead and write down the formula that's going to guide our problem solving process. So the amount added from the time interval a to b is, generally speaking, given an add rate let's just call our add rate a sub r, okay? Given our add rate a sub r of t is given by amount added. Now, if you think about ARR for our continuum here, so you have amount, rate, and rate of rate. Remember, when you're coming down, you're differentiating, okay? Amount to rate, you differentiate. Rate to rate of rate, you differentiate again. But if you're going from rate to amount, guess what? You do the inverse of the derivative, which is integration. So when you're given rate and you want to find amount, you're going to integrate your rate, all right? And then, of course, we don't want to forget our initial amount, a sub 0, assuming that there was any, okay? So there you have it. Now, so the amount added is going to be given by the accumulation from A to B of the add rate times the infinitesimally small time intervals dt. Alrighty, so if you integrate your rate, you get the amount. Basically, that's what it's showing us here. And then what we're doing is we're estimating this integral. Remember, you can estimate integrals using geometry. You can use rectangles or trapezoids. In this particular case, we are asked to use right Riemann sum, so we're going to be using right Riemann sum approximation with 4 sub-intervals. Remember, for the AP exam, you need to know how to use your right, mid, and left Riemann approximations, and also your trapezoidal rule. Okay, so here goes the table that we're going to be using to estimate this integral right here. So let's go ahead and do it. Now we want to make sure that we have the correct information identified from this table when we're setting up our rectangles. All right, so let's adapt this particular formula to what we're dealing with right now. So in this particular case, the add rate, the rate at which grade is being added to the silo, is a function g of t. The lower bound, your starting time, is 0, and your ending time is, so you're going from 0 to what? 0 to 8. Perfect. Okay. So now these are the rectangles. You need to know where your rectangles are, what's the base and what's the height of our rectangles. So remember that for your rectangles, they always sit atop the independent variable. Okay, so these are going to be the bases of your rectangle right here, and then this will be the heights. So let's go ahead and find the base or the width of our rectangle. So our widths are going to be right here. Let me change my color. So the width of the rectangle is going to be right here. So we're going to go from 0 to 1. That's the width of the first rectangle. So from 0 to 1 is just 1. Okay. And then for the second rectangle, you're going to go from 1 to 5. So what's the change? 1 to 5, you subtract that, you get 4. That's the base of the second rectangle. And then for the third rectangle, you go from 5 to 6. 5 to 6. What's 5 to 6? That's 1. That's the base of the third rectangle. And then from 6 to 8, what is that? That's 2. Okay, that's how wide the fourth rectangle is. So we have the basis of the 4 rectangles. So what are the heights? We're using the right Riemann sum, so we're going to use all the heights to the right of the left endpoint. We have 5 heights here, 1, 2, 3, 4, 5. Since we're doing right Riemann sum, you eliminate the leftmost endpoint and just use the right ones. Okay, so this is the heights that we're going to use for triangle 1. This is the height that we're going to use for triangle 2, the height we use for triangle 3, and the height we use for triangle, I'm sorry, I keep saying triangle, I meant rectangle. Okay, so rectangle 1, 2, 3. These are the heights right here. Okay. So let's go ahead and put it all together. Now it's just basic geometry that we're going to be doing. So the amount added on this interval 0 to 8 is the integral from 0 to 8 of g of t. Now we don't have to add the initial amount. Guess why? Because we're not asked for the total amount. Okay, we're asked for the amount that was added. Okay, so if you're asked to look to find the total amount, then you have to include the original amount. Now, in this particular case, it wouldn't have even mattered. You know why? Well, it's because the silo was empty at the start. Okay, so this is just the amount added. If they say how much was in the tank, what's the total amount in the tank at t equals 8, then you have to consider how much was there, the initial plus the amount added. Okay, all right, we're going to look at that later. So let's go ahead and do this. So we are finding this integral. We are estimating it using the right Riemann sum with 4 sub-intervals. So we have rectangle 1 is 1 times 1, let's see, 1 times 15.1, sorry, 1 times 15.1, that's for rectangle 1. For rectangle 2 is 4 times 20.5, so base times height, base times height, base times height for rectangle 1, 2, 3, and 4. Okay? 1 times 18.3, and then for the fourth rectangle is 2 times 22.7. All right, and then you can just calculate that with your calculator, and then you end up with 160. So what's the unit here? This is an amount, so the unit is going to be cubic feet. All right, so let's go over the unit again just for a refresher. So we have amount, rate, and rate of rate. The unit for the rate was cubic feet per minute. All right, now when you're differentiating, you're dividing by time. When you're integrating, guess what? You're multiplying by time, so it's going to become cubic feet. All right, and then the rate of the rate is cubic feet per minute square. So that's basically why we have 160 cubic feet for the amount, because amount doesn't have any time component associated with it. All right, so how was this graded on the AP exam? Let's take a look at that real quick. So for this one, you get 1 point for setting up the integral. You get another point for setting up the products that yield the areas of the rectangles, and then you get another point for the correct final answer. So just remember that you always have to show your calculus. All right, write down all the intermediate steps that lead up to your final answer. All right, let's take a look at part C. In this case, we're going to be looking for net amount calculations. So let's do it. Problem 3, 1C reads, it says, the grain in the silo is spoiling at a rate modeled by W of t equals 32 root sine pi t over 74, where W of t is measured in cubic feet per minute from 0 to 8 minutes. Using the result from part B, approximate the amount of unspoiled grain remaining in the silo at time t equals 0. Okay, so let's go ahead and write down the formula that's going to guide our problem solving process. So it talks about amount remaining, okay? So in this particular case, we're looking for a net amount, okay? So you had some initially, some taken out, some put in. So we're looking for the net amount. So for the net amount, all you just have to do, net basically means in minus out. We're going to calculate the amount added, okay, minus the amount removed. It didn't just ask for the net change, right? What was the change? No, it asked for the amount left. How much was remaining? So we look at the amount added minus the amount removed, but guess what? We also have to add the initial amount, okay? Because the question says how much was left in the silo, so you also have to consider the initial amount. All right, so there goes the formula. Now we're going to be using the notation, the net rate, so let's call it N of t. The net rate from A to B is going to be, if you want to calculate the amount added, you're going to have to integrate the add rate, so from A to B of the add rates with respect to time, minus the amount removed, so we're going to look at the integral from A to B of the removal rate, all right, with respect to time, and then we're going to add the initial amount to this. In this particular case, the add rate is what we did before, is G of t, and then the removal rate is this WT that we have here. Now let's go ahead and specify exactly what each of the components mean. So let's write it down. Solution is as follows. The let's say a sub r of t is basically G of t, and this is the add rate. Okay, And then R sub R of t is this new function that was introduced to us, W of t right here. This is the removal rate. In this case, removal rate basically means it's getting spoiled or it's getting rotten, okay? So removal rate. Okay, so let's put it all together. So the amount of grains remaining from 0 to 8 is going to, net amount is going to be the integral from 0 to 8 of the add rate, amount added. So the add rate is g of t minus the integral from 0 to 8 of the amount removed or the amount of grain that got rotten, w of t. Okay, another thing you want to keep in mind is make sure that your intervals line up, okay, because it says it started to spoil on the same interval. In some questions on the AP exam, the intervals might differ. So for example, it could be from 2 to 6, okay? So the interval for the add rate and the removal rate are exactly the same here. So it's nice, but it's not always the case, okay? And then we also have to consider how much silo was in how much grain was in the silo at the start, and it was none, so it's just 0. Alrighty? Okay, so if we work this out, it's going to become, well, basically, we're estimating, right? We're asked to approximate. So to carry out the approximation, why are we looking at approximation? Well, this is because in order to figure out the amount of grain that was added, we do not have a function to integrate. In part B, we used the right Riemann sum to estimate the value of this integral. So remember what the answer was? The answer was 160.8. Okay? Minus, now this one we just plug in the integral, this integral into a calculator, the integral from 0 to 8 of the w of t function. If you plug that into your calculator, you get 99.0515. And then if you subtract these two, you get 61.749 cubic feet as the amount of grain that's unspoiled. Okay. All right. Are we asked to explain? Well, let's just write down what the answer means, just for kicks, even though you weren't asked to do it. So what does this answer mean? The meaning of the answer is as follows. The approximate amount of grains, the approximate amount of grain, amount of, not just grain, unspoiled, okay? Unspoiled grain in the silo at the time t equals 0, no, time t equals 8 is, this is just an approximation, 61.749 cubic feet. Now, how was this graded? Well, on the AP exam, you will get 1 point for setting up your net amount calculation integral, so 1 point for that. And then you get another point for getting your correct answer. So this is a 2-pointer. 1.1 plus 1, you get a total of 2 points for question number 1C on the AP exam. All right, let's take a look at 1D, the last part. So it reads, based on the model in part C, is the amount of unspoiled grain in a silo increasing or decreasing at time t equals 6? Show the work that leads to your answer. All right, so let's go ahead and do it. Let's start by taking a look at the formula to help us to determine if a rate is increasing or decreasing, okay? So if an amount, if an amount is increasing or decreasing. So the formula is as follows. So increasing or decreasing net amount. All right, we're going to call it N of t. Now, why are we calling it net amount? Because we're looking at unspoiled, okay? Unspoiled is a net because it's a combination of the amount that's added minus the amount that's removed, or the ones that got spoiled. That's why it's a net, okay? Plus, of course, the original. That's why we're calling it the net. All right, so increasing or decreasing net amount basically depends on the sign of the rate of change of the net rate, okay? The sign of the net rate, n prime of t. All right, so is the derivative of the net amount function positive or negative? That's what basically tells us what's happening. And just to help you see, let's take a look at our non-chart here. So n represents net amount, up, concave down, increasing or decreasing. N prime, which is the rate of change of the net amount, increasing, decreasing, positive, negative, and then rate of change of the amount. Okay, so if we want to know if the net rate, the net amount, not net rate, if the net amount right here, n, is increasing or decreasing, what we're going to be looking at is the sign of the derivative of the net amount function. Okay, so what's the sign of the rate of change of the amount of the net amount? So that's what we're looking at. So let's go ahead and write this down just to show you what the function of the net amount, the net rate, is going to be. The net amount is the amount added, right? We did this in the previous problem, minus the amount that's removed. That's a net amount. All right. Of course, we want to add the original plus the initial. Now, if we want to get what the net rate is, or the rate of change of the amount that's left in the tank, in the silo, n prime of t, the derivative of the net amount function, guess what we're going to do? We're just going to differentiate these functions right here, and then it's going to give us the add rate minus the removal rate. Isn't that cool? So just the difference between the add rate and the removal rate evaluated at a particular time, that automatically tells you if the amount of unspoiled grain, or the net amount, is either increasing or decreasing. Okay, it's pretty straightforward. So let's go ahead and adapt this formula to the particular scenario under consideration. So all we just have to do in this particular problem is to find the sign of the net rate. Find the sign of n prime at the specific time, which is 6. What is the sign of the net rate at t equals 6? Okay, so n prime of 6 is basically going to be the add rate at 6 minus removal rate at 6. We already know that the add rate is g of t, right? And then the removal rate is the w of t function. So the net rate at 6 is going to be the add rate, g, evaluated at 6, minus the removal rate, w, evaluated at 6. Okay, so you just use the table for g of 6. If you use your table, you get 18.3. And then for w of 6, you just plug 6 into your calculator. And then you're going to get the spoil rate at times t equals 6, and that's going to be 16.0632, okay, which is equal to 2.2368, which is greater than 0. So remember, all we cared about is the sign. Is it positive or negative? Since it's positive, guess what? the amount of unspoiled grain is increasing. Okay, because we're looking at this particular case. If the net rate is negative, that means the amount of unspoiled grains, or the net amount, is increasing. Okay, so let's go ahead and write down what the answer means. Since the net rate at t equals 6. Now you need to understand what net rate is. Okay, net rate means the difference between the rate coming in and the rate going out. All right, coming in is the add rate, and then going out is the rate at which the grains spoil. Okay, so that's what the net rate is. Well, hey, we have it right here. So since the net rate at t equals 6, which is equal to n prime of 6, is equal to which is equal to g of 6 minus w of 6. Since this value is greater than 0, or you can just say since it's positive. Okay, since the net rate is positive, then you just write down what conclusion you can arrive at. Since the net rate is positive, the amount of unspoiled grains, let's write that again, the amount of unspoiled grains is increasing. Okay, the amount of unspoiled grains in the silo is increasing. All right, so that's that. All right, so this is a 2-pointer on the AP exam. Let's go ahead and talk about how you scored, how you get the 2 points. You get the first point for figuring out that the net rate is negative, and then you get your second point for explaining your reasoning. How did you arrive at that conclusion? Okay, so for this particular problem 1D, you get a total of 2 points. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your preparation for the upcoming AP exam, do give us a like. Your positive feedback is very valuable to us. Don't forget to subscribe to our channel and share it. We upload videos to our site on a regular basis. If you have any questions or special requests, just post it in the comment section below, and we'll be more than glad to support you. Tons of support resources to help you pass the AP exam can be found at mathgotserved.com. Do check it out. Thanks again for watching, and have a wonderful day. Goodbye.